Yes, all right, let's look at the following graph. We don't necessarily have a function given to us, like x squared plus 2x minus 3 and stuff like that, but we know that this graph, all of this, is in fact represented with the position f of x. Okay, so we are taking a definite integral from 0 to 2 of this graph. And what that means is from 0 all the way to x is equal to 2, we're going to analyze where does the area between the graph and the x-axis occur. In this case, it will be right here. Guys, since we don't have an equation, how do we do this? Not a Riemann sum. A lot easier than that. Pi r squared divided by 4. We know the area of a circle is pi r squared. This is a quarter circle. The radius, anybody, is what? 2. So the area of the entire one would be 4 pi. So whatever that is, 4 pi units squared would be the area if I were looking at the entire circle here. But because I'm only looking at that bottom right corner, I'm basically going to take this answer of a whole circle and divide it by 4. Okay? So that this area that we are highlighting is just pi units squared. Now, why do they have a negative pi, though, in my answer? This is huge. This is where all the negative mistakes come from on graphs and functions and stuff.
It's going like the opposite direction from the to the other quadrant, like the bottom right quadrant.
Okay, so this is big. This is big what I'm about to say, okay? When we integrate, okay? Typically we integrate left to right. Okay? So the low value here was 0 and the high value here was 2. Are we integrating backwards if we integrate from 0 to 2? Yes or no? We're not. If we're doing left to right. So whatever it is, that's the answer. But the reason why this is going to be a negative is not because it's backwards per se, which can sometimes happen. We have a lot more practice to get that under our belt. But the fact that it's below the x-axis. Okay? One of these essential questions that I have for you are, how are indefinite and definite integrals similar and different? Okay? Definite integrals, the area underneath the curve can be positive, but it can also be negative. Okay? It can be negative because of the fact that this is representing displacement, change in position. So any negative values, like saying on a graph, all of these values are negative y values. And a change in position or y values, anything below the x-axis for a position function will be negative. Okay? So that'll be a negative pi. Let's go ahead and do from 2 to 6. Alright, so the next question is B. I'll just start from scratch. And we're going to go from 2, so x is equal to 2, all the way to x is equal to 6. And we want to find the area underneath the curve. So we're just going to defer back to geometry. What's the shape that you see that we're trying to find the area of? Triangle. What's the area formula for a triangle? 1/2 base times height. What's the base and what we shaded? 4, right? It's from 2 to 6. So that is 4. And what's the height? 2, because of this y value here. So it's going to be 1/2 of 4 times 2. Anyone? Which gives us an answer of what? 4. Why is it positive? Because it's above the x-axis. Okay? Graphically, again, area below the x-axis is negative. Area above the x-axis is positive. Now we're going to go from -4 all the way to, so -4 is here. And we're going to go all the way to 2. Okay? So all the way here. And we're trying to find the area between the graph and the x. Always between the graph and the x. So again, from here you're just going to have a small triangle, 1/2 times base I'd say that's a base of 2 and a height of 1. Okay? And then we're going to add it with a half a circle. So pi r squared cut in half. And we know the radius, again, we said was 2. Okay, so you have 4 pi over 2 is 2 pi. And then you have this as 1. And why is it negative again? Because it's below the x-axis. Are we good? Alright, so negative 4 to 6 is saying everything, and you're just going to add everything together. So far you have this negative answer that you're going to add to what we got from before. What did we get here, guys? 4. So we're going to add 4. So let's distribute, because here's where the negatives occur. We have negative 1 minus 2 pi plus 4 is how they got negative 1 and 4 become 3. So you get 3 minus 2 pi. Then we have a couple more questions down here, E and F. Let's look at E's, the one that normally gets people. It's the absolute value of what you see. So this is now going to become here, and that goes here. Alright, so let me fix that a little bit. So when you see the absolute value, you know that this function is not going to be below the x-axis. So all of this over here basically gets reflected, and it no longer is going to be interpreted as negative area. Okay? So remember over here we got negative, this negative 1 plus 2 pi. Well, now because it's absolute valued, all of this area right here becomes 1 plus 2 pi. So positive, and then you get, what did we say that one was again? I keep forgetting. The triangle right here, what is this? 4. So that's how you would get this 5 plus 2 pi. Are we good? Graphical tends to be the piece that students struggle with more, but that's another reason why I want to record these videos so that you can go back and see. Alright, negative 4 to 6. So we have negative 4 to 6 of f of x plus 2. And the reason why this one's a little bit different is, what did we do to the graph? We added 2, so we shifted. Transformations are huge. If you're solid with transformations, graphs are easy, okay? So this whole thing pretty much got shifted up 2 units. So we're not going to say if it all got shifted up, that means it got shifted up 2, and it's from negative 4 to 6, that's 10. We're just going to add 20 to it. A lot of people think kind of like that. That's not how that works. But we're saying everything got shifted up 2 units. You with me? So yes and no as far as this interpretation that I'm showing you here. The best approach is to apply this to both. So from negative 4 to 6, we're going to look at the area underneath the curve. And then we're going to add from negative 4 to 6 what this would be. Okay? So if I'm looking at this, what was the area between negative 4 to 6? We got this from the previous problem was 3 minus 2 pi. Okay? And if I'm going to take the antiderivative, what's the antiderivative of 2? 2x. So for the first one I use the graph, but for the second one I'm actually going to get this 2x from negative 4 to 6, and I need to figure out what this equals. Okay, let's plug in 6, and now let's plug in negative 4. So we get, in fact, this one would be 20. What I was telling you as far as the interpretation, depending on what these are as far as positive and negatives, can throw off as far as, are you just going to add 20, or does a displacement of some sort happen, or some pieces cancel out, vice versa. So this one I would just end up adding 20, so I get 23 minus 2 pi as my final any questions. That was a huge one. This is a really, really important.